Hi, my name's Gordon Dunbar, and this is a short video on how to apply the theory of constraints to prioritise projects. You can see that the approach I'm taking is to draw an analogy between this pipe and a business. So the approach here is that this pipe has different sections to it. Each section has a varying diameter. And we have water flowing through this pipe from the top, gravity fed through to the bottom. For the purposes of this exercise, we're going to assume that we've got unlimited water and we've got unlimited capacity to remove the water from the pipe once it's passed through. So the question then arises, and that is, if we wanted to increase the capacity of this pipe to enable more and more water to flow through it, where would we invest our effort and our resources to do that? And I hope that you would come to the same conclusion as I, and that is that section E would be that section where you would increase the capacity. So if indeed each of these sections were departments in an organisation, and each manager was responsible for identifying investment opportunities for the pipeline, then the question that the owner would have would be, how would I determine which projects to work on, or which projects to invest in and which projects not to? And it should be evident that the answer to that question is section E would be where that owner would prioritise investments, at least initially. To labour that point, or to emphasise it a bit more, the question is, if he was to invest any of his money or her money in any of the other sections in terms of increasing their capacity, would that help the pipeline's performance? And the answer should be no, or is no. And the reason simply being is that the capacity of each of the other sections is far greater than the capacity of section E. And so by increasing the capacity of those sections would not deliver one iota of benefit for the pipeline as a whole. So as a result of that simple approach to business, Dr. Goldratt came up with what's referred to as the 5 focusing steps, and through refinement you'll see that there's actually a step 0, and that step 0 is to define the purpose of the system, and you will recall that I laboured that point when we talked about the pipeline, because the purpose of the pipeline, i.e. to maximise water flowing through it, is pivotal in terms of the subsequent steps that the 5 focusing steps talk about. So once we defined that the purpose of the system was to maximise water flow, we can then move on and say, well, the first step in the 5 focusing steps is to identify that constraint, and you'll recall that we talked about section E being that. Step 2 is then to exploit that constraint, and exploitation refers to any activities that will increase the performance of that pipe or that section, which will not necessarily require an investment of money. So for example, it might be that that section of the pipe has debris in it, and that's in some way limiting water flowing through it. So exploitation would be to clean it, to make sure that the debris was removed, and that in so doing would increase the capacity of that constraint area by what could be a minimal or a substantial amount, depending on the amount of debris in it. But exploitation is about being smarter with what we've got, trying to improve the capacity without any investment. So after we've exploited those opportunities of improving the performance of the constraint without necessarily investing any money, the next step is step 3, and step 3 is referred to as subordination. Now, subordination in a pipeline sense might sound a little bit clumsy, but what it means is that the organisation recognises that any downtime on the constraint is a downtime for the whole system, that the performance rate of the constraint is the performance rate for the whole system. And therefore, if for example we have maintenance crews working in all other sections with the same priority as they are for section E, then that's not subordination. What subordination would require is that if there's a maintenance requirement at the constraint, then all other maintenance crews and resources would stop working on their own sections and prioritize the section of the constraint. If there was a blockage upstream of section E, then again the priority would be to make sure that the constraint is never starved of any water, and that would be the priority in all instances. That the constraint is also not limited by the flow of the water out of that section, so that if there was a blockage occurring downstream of the constraint, that again there would be prioritization given to that to ensure that the constraint is never starved or blocked or down for any reason that couldn't be controlled. So subordination is an important activity and gives credence to the fact that the constraint is the thing that determines the performance of the system as a whole. The next step is step 4, elevate the constraint. The reason why this step's been left until step 4 is because it's quite possible that the constraint would have been removed by either of steps 2 or 3. So after exploitation, for example, the debris that was removed during exploitation may have really had such a profound impact that no physical capacity increase is necessary, or that the subordination activities of step 3, by having maintenance focus its priorities on the constraint, also achieve that end. And so we only invest in step 4, which is what elevate means, if steps 2 and 3 were not successful in causing the constraint to move somewhere else. So just to summarize, elevate the constraint is that step where we legitimize the investment of funds to improve the performance of that constraint. And this step is typically the step that occurs in a project sense, because the projects necessarily are assumed to require an investment of funds. However, you can see that the 5 focusing steps says that really there are 3 preceding steps that must be embarked upon before any consideration of a project investment is made. But indeed, if it hasn't moved somewhere else, then yes, we are entitled quite legitimately to invest at that point. And this is really where the projects need to focus their attention. But however, once the constraint has moved, then that investment should stop, and we go on to step 5, which is to avoid inertia and go back to step 1, which essentially means that whilst we've removed the bottleneck in the first instance, it's quite possible that, or will be the case where the constraint has moved. And if we go back to that diagram, you'll see that if we expanded section E, which was our first bottleneck, if we expanded that to out to here, for example, then you can see that the very next bottleneck would be section B, which is the next thinnest diameter. And so using the 5 focusing steps, we would then be able to prioritize projects on the basis of where the bottleneck has moved to, and then from there go through the 5 steps again. As we do that, eventually, of course, this pipeline would be expanded and continue to expand, but in the right way and in the right sequence, avoiding unnecessary investments in projects that would not deliver value to the overall system.